Says I'm live. Hello, everybody. All right, welcome to another stream in which we're going to do some development on XR tools. I want to do a little bit of housekeeping first, and after that, we are going to start looking into implementing a teleport function. In some ways, I'm going to go a little bit simpler than what I did, many years ago in XR Tools 1. But I also want to look at some wishes that were made over time, depending on how much time we have today, how far we get. But seeing if I can implement those properly. There are some additional difficulties in the way that we do things in XR Tools 2 that make that have an interesting impact on doing a teleport. We'll see how we go. Now, a bit of housekeeping I want to do is actually around the XR Tools helper script, which is this one. That one can be found in the roots of the plugin here. And this is almost really becoming sort of like an XR Tools library script. So I don't actually like the helper nomiker. And seeing that we haven't got anything released yet, this will be a breaking change. But seeing that we haven't got anything released yet, I'm wanting to do this change right now before it breaks people's implementations. So if there is anybody out there who's already using XR Tools 2, please be aware this will be a breaking change. But yeah, it is one that I do think is important. Now, the thing that I'm not sure about yet is the name. I am tempted to just call this XRT2 as a class name and not have helper at all. Or maybe lib might be an interesting name too. I am not 100% sure there, but I don't like helper in this case. The other thing that I am going to do is organize these into code regions just to make things easier to find. So, and that's especially important for the collision exception logic. While we're in here, we might also quickly go and change this to have a delay in there. That's the other thing that we ran into yesterday that I really wanted to add in here. Alrighty, so where to start? Actually thinking about this some more. If we just name this XRT2, it's going to be hard to find stuff. So I'm actually put that in here. I'm very tempted to just call this XR2 lib. Or do I indeed just call it, XR2? Which, by the way, is the other thing. I discussed this during the stream yesterday. I'm thinking about renaming this whole library itself to just XRT2 instead of having it completely written out as XR Tools 2, simply because of the versioning and the confusion around that. So maybe naming this by that might be better. Yeah, I think I'm just going to leave it like this. I think that makes far more sense. So this will break everything right now. That actually means that I really want to close everything here. We're going to rename the file in a minute as well, but I want to start with just doing that. Find in files, XR2 helper, find them all. There we go. So obviously we are going to have to rename to this just XRT2, XRT2. Okay, so we renamed all those. So that can be saved and here as well. XRT2, XRT2. So we just got those in here. XRT2. Here also XRT2. Now the nice thing that you know, although in this case, because we are doing static functions and therefore just a prefix, it's not going to help us much. But obviously the UIDs, once we rename the file, the UIDs should protect us to anything that's linked to the files. Wow, this is everywhere. Okay. Again, there. You know what? Why don't I do it like this? Oh, that's... I'm tempted to do a find and replace, but in this case, I kind of want to double check that I don't have something weird somewhere. So yeah, it might seem like the long way around, but I don't really trust search and replace in these cases because it is easy that there's something somewhere where we end up replacing too much. Okay. That's all that. So now we can go over here. Boom. Boom. Now we go over here. Okay. Yeah, you can't do that because that is probably still wrong. But we'll get there. Okay, is that the movement provider? No, that's self-reference and helper. Okay. Here's a door handle that we wrote yesterday. I'm planning to continue on that and make improvements, but right now I want to get through my list of open issues. Let's just do a find again. That's now all cool. Also, one of the things that I really want to do is do a close all here and clean up a little bit. Now over here, we just do a rename to just calling that xr2.gd. Yeah, obviously. So I think at this point, probably just want to do a reload current project just to make sure that, yeah, there we go, that everything is nicely clean in memory. I don't know why it starts with this. Oh, that's because that's our default scene, of course. All right. But now we just have the xrt2 file here that is nicely renamed. So let's clean up this file a little bit. Obviously, we need to change that. Oh, let me just stir my fan off. It's getting a little chilly. There we go. Right now, I'm going between it is too hot and it is too cold. Always in a nice time of year in that respect. All right, so there we go. We now have our xr2 library. Now it's I'm likely going to turn this also into my plugin script because I don't think I have that yet. No, I don't. So I do plan to add a plugin header around this so that we can install some tools. But that is, I think, for a future video. We're probably going to remove this as a comment, but for now, we just want to go and see what are all these functions. Yeah, up until here. So we want to turn that into a code block. Why you create code region? Alrighty, that should have gone directly there. Oh, it's done that. Yeah, right. So these are. What is a good name for that? Yeah, just do node lookups or something. Node access. All right, so we no longer want that. And basically the first block here are functions to get our different nodes. So we have a helper function for getting a controller node. Not 100% sure why I put that here and not inside of the controller node itself. Oh, that didn't open a script. That actually went to the documentation, although I might have a static function in here. No, that is for normal control. That's why. Okay, so that is why that is coming like this. And not one of the XRT nodes, but that's fine. So a general XR node here. So find a XR node 3D here. Find our origin within here. That goes down, I think. Yep. That goes down the pair. So this one also goes down. Or these all go down the tree. Okay, that's cool. So the character body. So these are sort of like the things that we use in a number of places where we just need to find stuff or find particular nodes. So they are nice, handy things. Now here are some functions that we use in our physics. So we have our angle and plane that I'm using with the climbing and making sure that a two-handed logic to make sure that I can rotate things correctly. There you go. We have a rotate axis. This is actually not specific to what Extra Tools does, but we basically get a quaternion difference between two orientations, and then we return that as what is called a axis angle vector. So that is a vector where the length encodes the angle of turn. So it's kind of like a quaternion, but not exactly. But it's kind of the same principle. And the nice thing here is that it allows you to encode an orientation in a vector 3, but also it allows you to adjust the rotation by changing the length of the vector. So let's say that this is an actual rotation speed around an axis, and you're saying, well, this is the angle that we rotate per second. I can now just multiply by delta to actually get the rotation per frame or per physics frame and do calculations with that. So pretty neat thing to use. And then obviously our apply force to target and apply torque to target functions that we written a long time ago here. Excuse me. These are used in the actual physics handling of objects to make sure that we apply the correct force and correct torque to get our required movement. All right. So these are XR2 physics helper functions. There we go. And I do not need that anymore. I think one space between these blocks is more than enough. All right. So now this, and here probably I am going to keep some of the comments. And here probably also where this is one of the things where I'm probably going to have to turn off the linter. Although it hasn't complained about it so far. Boom, 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 boom. Remove exception. Okay, so there we go. We're going to make that a code block. Fortunately, to scrub up again. And this is our XR22 collision exception handler logic. There we go. And then here we have some deprecated functions, which I will eventually remove. So that's deprecated functions. There we go. All right. And we'll probably do more here eventually, but that just cleans it all up a little bit and makes it easier to find the functions that we need. Okay, so here I just want to remove that, but I am going to leave these comments in place. But the other thing that I want to add here is a var delay float. There we go. Excuse me. Oh, okay. I think my my Steam VR session just timed out. Okay, so that is missing. We probably want that to be a constant. So delay default delay. So We're going to go up here and just define it as a const. Does that mean it need to be an equals 1.0? I think so. Can I get help for const? No, I can't. All right. However, we probably are going to want to reset this on a remove. So that's defined. Okay, down here we have our add collision. Here we have our remove. Excuse me. Count. So we have now reached 0. Now we want to do reset our delay just in case. And then we just have our note here. It will be freed when we no longer glide. So we're not freeing this immediately. We're doing it there. So now what we need to do is over here, say, okay, say if it's not valid, then gone. Else, if we reach 0, we want to make sure that we only do our collision check. Okay, so the easiest way to actually do this is simply say if set.delay is bigger than 0. Obviously we need to subtract that, but I'm just going to add I think that is a break. Set in pairs. We go through all of those. So yeah, I think, is it break or is it continue? Hold on. Now that is getting out of this loop. So that isn't break, that is continuing. That means that we skip over the rest of the processing here and we go to the next one. Cool. But what we obviously want to do here is set.delay equals, you don't want to get this below 0. Set.delay minus delta. Do we have delta in here? No, we do not have delta in here. And that's actually not delta. That is our collision check timer. When we look at our collision check timer, we have actually set that, so we can just do collision check wait time. Now, potentially more than that has passed, but we're going to assume that this is called nicely on time. So, and again, it's just to get a reasonable delay between us no longer having a link between two objects and us actually removing the collision state or the collision exception. Because the situation here is, for instance, when I'm grabbing the door handle, when I let go of the door handle, my actual hand might be like, say, inside of the door or on the other side of the door or somewhere where it is in a peculiar state that we will get into trouble. So we keep our collision exception between our hand and the door handle intact for, well, originally for as long as it's still colliding. But here we're adding a little bit more that we're also saying, well, we want to keep that exception for at least a second. And that allows us to have the user move their hand away from the object that we have just let go and not risk that object colliding with the hand and weird stuff happening. The same with if I'm holding an object and now I'm dropping an object. There are scenarios where dropping the object then suddenly means that, hey, I'm now colliding with the object and the object shoots off or something like that. There is, unfortunately, a side effect. There is, I'm grabbing an object that I want to hold in front of me and then let go and rest on my palm. That will now fall through my hand because I've got that collision exception. But yeah, in there lies a bit of a conundrum of what makes more sense. And seeing the amount of problems that are caused by objects being let go and then shooting off because the hand is actually now inside of the object, it's better to do something like this. So yeah, that is just a thing. And maybe we'll make that a setting at some point. Oh, I think my sound went a little bit too loud there. Maybe we'll make that a setting at some point. You know, if you really want to make sure that that isn't a problem, that we'll let go of the object and we keep the collision situation intact. For now, we are playing it safe. All right, so this is something that I want to test to make sure that I didn't screw something up. And indeed, Steam VR was nice enough to close down. So did this even go to sleep? I think this even went to sleep. Come on, there we go. All right, so need to wait until it has connection to my network. Come on, find my computer. There we go. Let's go turn on Steam Link again. There's Steam Link, and now I should be able to run this. Cool. All right. Sweet. All right, so this should all still work. Boom, boom. Yeah, just fine. And now just to show, like I said, if I let go, it actually falls through the hand because we're no longer colliding. But after that, we can do that. Now I can do this. And you kind of see the problem here is it falls on the hand, and the hand sort of moves down because of the weight of the box, and then moves back up to where my hand actually is, and we sort of bounce the cube off. If we do it more closely, then it is nicely on my hand. But yeah, the situation that we kind of want to avoid is the situation here that I'm showing now, where my left hand is actually inside of the cube, and now if I would let go, if we did not have that exception code, it would actually make the cube fly off, and that's the situation that we're trying to prevent here. So cool. I am happy that that seems to work the way I am expecting it to work. Cool. And again, most of that would already work because just of the check of not releasing those exceptions until we no longer have collisions, but we now have safeguarded that it also doesn't happen. If there's a reason that the collision no longer happens, but the hand is in a weird spot. I don't know if anybody remembers from yesterday's stream, but I had situations, for instance, where the hand would get stuck between the handle and the door. I'm going to turn this down a little bit because it keeps going in the red. So of the hand getting stuck between the door and the handle, and then you have to move far enough back that the hand teleports before we actually have a resolve there. Okay. Cool. Yeah, that's fine. I think that's all that I want to do here. So let's save that, and let's just quickly go, and I'll do this. Actually, oops. We'll move that over here for now. So in this case, just for these changes, I'm going to make a new branch, and that is going to be rename helper to main whatever. It's dots. Let's see if that looks correct. There we go. So here, rename T2 helper to actually 2. This has a bigger role. All right. So let's go and push that one into our repo. so that the rest of the functionality that we're going to do today is separated from those changes. And I will create the PR later on. I don't have to do that right now. Okay, so with that, we should start having a look at teleports. All right, cool. All righty. So the idea that I have with the teleport is that we're going to simplify it a lot more than the old teleport worked. So the old teleport function in XRTools 1 actually looked at a collision shape, and it will move that collision shape along an arch, along the teleport arch, to see if it could end up where you are pointing. And in the new one, I want to just keep it much simpler. We're just going to cast a ray downwards. I'm going to make sure that it always points towards the floor. And then wherever that ray hits, that's where we're going to move to. And we're just going to see if we can actually move our player to that location. And for that, I'm still sort of wondering, like, okay, are we going to check for the full height or the full player size? Or are we going to do something a little bit more simple? Or are we just going to check, okay, if there's nothing in between, if the raycast doesn't get interrupted by anything in the scenery, are we going to be able to move the character there? Because one of the things that is a risk with these sort of approaches is that we could allow a player to teleport into a location that they're not supposed to enter. Let's say that you want to teleport through a window into a room that has a closed door. Obviously, that is something we want to prevent. Now, the other thing that I want to change is the way that you engage the teleport. In XRTools 1, it was always the trigger. Hey, Drifter! But I actually want to change that to default to a press down on the joystick. And when you press down on the joystick, I want to disable the other movement functions until you release it and you actually teleport, or cancel the teleport if needed. So that is what we are planning to do right now. For that, I do need to have a look at the fact that we don't actually have an input for that yet. I actually also want to remove the trigger click. That's another good point. Let's do that as a small distraction. For that, I want to go to script. I want to make sure that we're not using that anywhere. I think I already changed the way that works. But we do have these as the default ones. Because what I did do here... Oh, that's set on to the hold button. Okay, so here's where we actually use that. Check if it's an action, then true. If not, I'm looking at here. Oh yeah, and I'm already checking the type. Yeah, maybe I should leave that in the action map then. Glad you are having fun with XRTools 1. It'll take a little while before we have everything implemented in XRTools 2. That is currently in XRTools 1, but I do think we have enough in there now that you can actually use it for a game that you want to build. But yeah, I'm really hoping that this month I will make a decent dent, or maybe even get close enough to where I want to be for XRTools to be considered like for a first version. So yeah, but cool that you're enjoying XRTools 1, which is something we're still very proud of. Anyway, so yeah, I do have that as a default here because I'm using the names of the default action map. But I'm tempted to just make this trigger, to be honest. I think so. I kind of like having the situation where... So that has now become the default. I kind of like having a situation where this is actually using the floating point input so that we can use our own threshold logic, because in some of the runtimes, the threshold logic for trigger click is not as good as I'd like. Yeah, so with this on the loading screen, yeah, that's now, because that was already set to trigger, because I wasn't using the default anymore there. So with that removed, I can actually remove the trigger click from our action map, because I like for our, actually I'm going to rename this to Godot XR Tools action set. I need to sneeze. Hey, excuse me. I also need to add a sort in here. I'm trying to keep this as brief as possible, so that we're just using the entries that are actually used in our demo. Also, as an example of that we don't really need a complex action map for a lot of things. Oh, thank you, Sean. I am glad you guys are enjoying what I'm doing here. Okay, so yeah, well, that's the other thing. The simple controller is actually really limited. Now, I do think that with this, probably the trigger click was still used for select. I should have double checked that, but I should be able to just marry that up to the trigger, because the select click is mapped on most controllers to the trigger. But even if you map a Boolean to a floating point, there's logic behind the scenes that we convert the input from true, false to 0 and 1. So that should all be fine. But yeah, the simple controller is pretty useless. I'm sorry to say. But the other thing, of course, is that we now want to do something to enable our teleport. So in this case, we're actually going to start creating an action that is specific to that. So just like we actually called move for move character, which is still a bit of a misnomer in this case. Yeah. The official way, by the way, which is something that I'm hesitant to use, but officially what OpenXR would like us to do in a situation where when we enable something like a teleport is actually disable the XR tool or the main action set, and then enable a teleport action set that just has the inputs for the teleport. I don't actually think that works very well. So so yeah, I'm hesitant to do it that way. Now, do I want to do a specific teleport activate action? Yeah, I think I'm going to do that. So we're going to add a new action here called teleport, and we're going to call that enable teleport, and that's going to be a Boolean. Now, unfortunately, on the simple controller, we really don't have anything to link that to. We don't have a joystick input on the simple controller. I really dislike the simple controller. Now, there is a new generic controller that was added to the OpenXR spec, which we have added support for in 4.7, if I recall correctly, but no one supports it yet, which is really, really annoying, because I would love to replace the simple controller with the generic controller, and that actually does have inputs for what we need here. So what we're going to do here is, when we look at our thumbstick, we obviously have our thumbstick input itself linked to move. We're going to link our thumbstick click to our teleport enable. And I'm going to do the same thing here. Now, here is another thing where I'm deviating from the way that OpenXR likes us to do things and the way that I like us to do things, is that OpenXR wants us to just have this action on the thumbstick that we are using for teleport, which means that I need to pre-decide whether that is the left hand or the right hand. I don't like that. That makes it hard for me to make something for a left-handed person or right-handed person. So I put the enable teleport on both. And instead, what we are going to do is we're going to add our teleport node to the hand that does the teleport function, which means that if a left-handed person wants to move that to their, because I'm going to default this to the left hand, if they want to move that to their right hand, all that we need to do is reparent that node to the right hand, which we can do very easily. And because our scripts listen to the inputs of the hand that they are a child of, they are automatically only going to listen to the teleport inputs for the correct hand, which is what we want. So we suddenly have made it really easy to move functionality between one hand and the other. And obviously that same applies to the direct movement, where we have the one on the left hand configured for strafe, I believe. No, this one is for rotation, and on the right hand we've got it for movement and strafe. But we can do something very simple to flip them around or to change the values. Depends a bit on what we like, to make a menu toggle for flipping those around. And I think that actually will be a nice stream to do at some point, where we create a UI where someone can say, like, yeah, I want to flip those. And we add some code and we say, all right, move the teleport to the right hand, flip the rotate and movement around. And suddenly we go there. And for something like that, we might even go as far as renaming these and say, this is going to, actually, I might want to do that right now and say, this is going to be called turn movement. And this one is going to be called strafe movement. So we could swap those around and that would work. Hold on, just want to make sure that I don't miss anything important here. No, this is okay. So yeah, that is actually a nice thing to add in to this at some point, I think. But for now, we're going to stick with just doing the teleport logic. So yeah, I've got that now on the touch. Now obviously I need to do that for the other ones as well. So here we have our thumbstick, and we also have a thumbstick click. So we're going to go and create that, and we're going to go and create that. And then on our hand interaction, we are going to leave alone right now as well. But it is something that I want to look at some point. Is okay, how can we do this for hand interaction? And with hand interaction, we might actually need to do something completely separate from our action system. Unfortunately, the number of gestures that the hand interaction support is very limited. Ideally, I would love it if there is another hand gesture that I can do, because we got our pinch and we got our point and we got a grab. But I could imagine that we could do some sort of hand gesture where you put your thumb on top of your hand, to when you make that enables the teleport, and then maybe by moving or moving the finger we could rotate, because that's the thing that I'm going to use the joystick for. And then obviously, you point to where you want to teleport, and then when you let go, you actually teleport. So if we would have that gesture as part of the hand interaction, we could do that, but we don't. I might eventually do something where I say, like, okay, we're going to start recognizing those gestures ourselves when the hand interaction is running, or we're doing hand tracking and not controller infer tracking. And we could do something like that we recognize that gesture and say, okay, if we have that gesture, we actually issue the teleport event ourselves at that point. That's future music. I'm not going to do that today. That is a whole different story, and we'll start looking at that at some point. So for now, the hand interaction I'm going to leave alone. Also, obviously, I can't use that on the frame anyway, so that's for future music to add in. For the frame Steam controller, obviously, we have the same thing, the thumbstick click. We're just going to add that to enable, and then here to enable. Cool. All right. So that sets up our action map, hopefully, and we should be able to detect our thumbstick click and enable our our teleport with that. All right, so like I said, I wanted to implement that initially on our left-hand collision, so we need to start with creating a teleport function. For that, I just need to have a look at our file system and figure out a nice place to put it. So I kind of want to make that part of our player structure. It's not really a movement provider per se. This is just generic components. And maybe you would just create a teleport folder here. Because it is specific enough that it deserves its own thing. All right. So we're going to create an XRT2 teleport GD. All right. New script XRT2 teleports. And that should already be .gd. All right, cool. All right, with that, let's go and copy that over. So that we have a copyright message there. That still say 2024? I don't know. And obviously that needs to get a class name. We're not going to make a tool there, but we are going to say class name XRT2. Oops, XRT2 teleports. And that becomes actually a node 3D. There we go. Excuse me. And with that, I should be able to add our XRT2 teleport. Hasn't picked it up yet. Do I need to save that first? Maybe. To teleports. There we go. All right. And of course it does that. That's fun. I thought I had that selected. Maybe I deselected that. All right. Let's zero it all out. Cool. So now we have our teleport function there. And actually, I suddenly realized that I do not want that to be a node 3D. But instead, I might, let's see what this is again. Oh, that's also node 3D. Where is the positioning for this one? Is that on the ready function? The reason why I'm checking this is because of our hand tracking, the origin of the controller is different per runtime, and it's different whether we are using hand tracking for positioning or whether we're using our palm pose. So in order to be less dependent on that controller position, I am now positioning based on why can't I think of the name? I'm now positioning based on the metacarpal bone in the actual hand object. I'm trying to remember, how am I actually doing the positioning here? Put any collision parents of our node. Oh yeah, that's an exclude on that. That's fine. Yeah. I was pretty sure that I did positioning on this, because one thing that you'll notice is that I'm actually hiding the transform here. So let's see, updating transform is true. Yeah. Oh, I'm doing that in our skeleton update because I've got my own skeleton update logic in here. So that is not a good example. Where else am I doing something with this? I don't believe that I do anything there. Maybe I'm remembering that I've done this in Actual Tools 1, but I haven't actually done this in Actual Tools 2 yet. Because here you can see that logic where I'm grabbing it from the metacarpal bone, And I'm saying like, that's where I want it to be. And the thing that I really want here is for that to be in a base class. So if we go and have a look at that, so where am I using this for? Okay, I'll do that both. So I think that we should move all that logic into a helper class. Huh. Yes, I do believe so. All right. Yep, that's cool. That's cool. All right. All right. This is going to be a bit of a bigger change than I initially anticipated, but we can get this to work. So we have our hand attachment and modifier and pose. So that is to get those out. This is the other thing, of course. No, I kind of want that to be something that we do from there. Okay, cool. So what do we call that? That's the big question. What is a good name for this? Because one of the things that is important to me is that it keeps working even if we don't have a collision hand, but that's something that we are actually already taking care of in the way that this works. Because we're kind of doing hand attachment here. Kind of basically re-implementing this. And that's the thing that I'm sort of wondering about. Do I want to I just want to go and make that our base class? Because that would kind of work. All right, so it's a hand attachments. Okay, get configuration. It needs to be a child of collision hand. And that's the thing. Do I want to make that mandatory or a warning? All right, so that is property name is bow name. Then we do that. So yeah, that's for setting it. Very cool. And 3 collision hands. So the difference here is that we are on the pickup, we are actually remembering that because we're using it in a lot of places. And in entity, we are gonna, so that's the other thing. I think the entity of the parent gets run before the child. However, does the exit tree of the child get run before the exit tree of the parent node? So that's kind of what I'm hoping for. So. Configuration warnings, okay. So here it is both, fine. And that's the thing that I'm wondering about. I don't think we allow um because yeah, this is designed to work either with controller or collision hand. Yeah, that's right. Okay. Yeah, there's a whole lot more things. Okay. All right. So collision hand is that one. Cool. Just going to leave the configuration warning as is. And I'll leave the validate property as is for now, but then our enter tree. Let's go and have a look at our enter tree here. So in this case, we have a, see, we have our get XR control. Yep, we have that. Perfect. So we're going to do that over here. And then we're going to say, if we find the collision hand, we're going to go and do that. What? Oh, yeah, because it is now no longer a local variable. There we go. That should work. Cool. And then here we can simply say, if we had a collision hand, get rid of it. And then obviously we'll set our collision hand as null. Oh, we need to do that same thing too. Okay. Cool. And then here, if we don't have a collision hand, we go bye-bye. All right, cool. Okay. Now, seeing this is a tool script, yeah. And we're now handling our collision hand on enter tree and exit tree. I think it's actually fairly safe to say that we can even say, if not that, we just give our warning. I don't think we have to get it here because the enter tree and exit tree already make sure that this is done. Also, I only want to execute this if we're there. Now, the last thing that I want to do is here in property is say, if we haven't, I can actually make that else if we have that. And this is something we're going to steal from here again. Where is our property? So let's go and copy this whole thing because that's what we want. So let's go and see that. So if we have a collision hand and our property is any of these, we are going to hide it because if we have a collision hand and we have those properties, we are actually setting the transform ourselves. So we don't want the user to update that. So here in update it, we say if we don't have a collision hand, there's nothing we can do. Well, if we're already updating, that's there is a possibility for this to get recursively called, so that's why that is there. Then obviously in this case, we are no longer caring about this. We are just doing that. And we're going to say, if we have a bone, then we are going to set that, and else we're going to reset the transform. Very cool. And with that, our tip attachment should be working. But I was actually expecting that to go. Okay, so that is hand attachment. That is what we were now working on. I think the reason for that is that we actually need to reopen this. All right, so now indeed, if we're on the index tip, we see that we can no longer edit our transform. We're not getting our warning, and it is in the right one. So if I change this, that is perfectly changing. That is perfectly changing. I don't think I am actually doing anything with that, so that's just a test. But with that, we now have our index tip attachment working the way we want. So I might leave the pickup alone for now. Really should be subclassing the or extending the hand attachment onto the pickup. We can trial that with the teleport and then make that work further. So our teleport script, we can now say, let's go and subclass that from this. And we might want to have a little bit more logic there, because I'm looking at our pickup. All right. Let me find one of the first ones. There we go. That function I actually want to have in here. Let's also just boot up our regions. So here, code region, that is going to be export variables. And then this is going to be private variables. And then this is going to be public functions. And then that is going to be private functions. Sorry. So with that, our XRT hand attachment is nicely cleaned up. Very cool. All right. So one of the things that I'm really wondering about is, can I, on the teleport, make certain warnings disappear? Because I don't know if this is a function that gets called on each, or if it overrides it. We can kind of test that by going to something like this. That should have now given me a warning. Oh, that is because when it changes. Okay, that's something that we can do over here. So on our enter tree, notification. Copy list changed. So, okay, let's see. So if I move that, so if I do that same thing again, if I move this somewhere else, it's not running that. Oh, because I didn't make my teleport function a tool script. And without that, it obviously is not going to work. So if I now do this, well, that's still not going to work because I think I need to go and reopen this. All right. So now if you move that there, yay, we get our, must be a child. If we move you back here, then that disappears. All right, that's also cool. I haven't had that working properly for a long time. And we kind of need to do the same thing in our other ones. Alrighty. Sweet, 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 sweet. Okay. So with this, first thing that I want to do, we'll make code regions here as well. And I believe that is no editor. Because we do want to save it, but we don't want to see it. Okay. The other one that we want to do here is on our ready function, we want to make sure that our name becomes, you are going to be, hold on, I'm actually going to go and copy that from our pickup function. I think that was all the way at the bottom. Yep. Oh yeah. Here we go. All right, that means that I don't want that in my ready function. I want that in my enter tree function. And obviously we're going to want to do, if we have a collision hand, we're going to set that to the correct one. So with that, let's go and reopen main stage again. And our teleport does not look like it's in the same place as our pickup. Okay, and that is that. Why are you doing that? Because we are here. So that should actually have that. Huh. That is weird. All right. Because that one is not giving us a problem, but that one is. That makes it really strange because it's running the same code. Uh-huh. Do I need to do this? Ah, okay. And actually, I can just shorten that to that. So that's actually kind of cool because that means that we can define when that is called. So the big question also is, does that need super as well? As in super property. All right, so with all these, we define whether we are going to call the underlying function. Cool. That also means that for our configuration warning, let's go and put this in here as well. So does this allow us to call super? Yes, it does. So in this case, if we're not a child, actually, no, what we're going to do here is, hold on. Tree. Yeah. Oh, am I only checking that here? Was I blind? Was it? Oh, because this is. I was seeing. I thought the function ended here. All right. So perfect. Do I need that here? Yes, I do. So I'm going to be doing the same thing. I'm going to be doing here is on enter tree. Else. We're going to go and get our XR controller. We indeed need to go and define that. No. Where is that? Somewhere all the way down here. Okay, cool. Could have probably done that myself, but anyway. Okay, so there we go. We have that. So here, what we can do, let's go and actually get to the warnings here. And we're going to say that. And we're going to do that. And then obviously we can say if not controller and not collision hand, then we're going to go and give a warning. Now, that means that, again, I need to reopen world stage because it needs to reinitialize that stuff. Why is it not doing that? Because it's going on script. Okay, cool. We can see that that's not in the right spot, but what I want to try is if I move that to here, now my warning is node configures both because it's running through my configuration warning on my teleport script. We're not calling super, so we're not doing the default logic below that. I don't think there's a point of then going one level deeper and calling that. I don't think there's any warnings that are important there. However, what I do want to do right now is add a controller node here just as a test. And let's go and move that under our controller node. And we can see, hey, our warning is gone. It's happy to be under a controller node. And it's happy to be under a collision hand. So eventually I'm going to change our pickup script as well to use this and do the same approach as our teleport. But for now, I want to focus on our teleport function and get that implemented. So with this, we now have our teleport. We have our collision hand from our inherited place. We are setting the correct bone if we have a collision hand. If we don't have a collision hand, if we're on controller, that means that our position is always going to be a default transform. And I'm actually very, I think that one of the things that I want to do is in this case, I also want to reset the transform just in case it has somehow moved, because again, I've made it kind of impossible to well, I made it hard to reposition it, and I don't want it to repositioned because I want it controlled. Now, one thing that is going to be important, and I'm actually going to go and put a note on that here. We should position our node based on the pose used for the controller. All right. Now, when we use palm, the offset will be different. So we are now on our metacarpal bone here because we can't really use the palm bone because we don't have a guarantee that that's there. So in this case, you know, we're here. Maybe we need to apply an offset. That's actually another thing that I'm thinking about adding to our attachment that we're here, but that we can actually add a transform offset here. Might actually want to do that anyway. So let's make a property for that. Oh, this actually should be the bone for our hand. Position this at, and in this case, what we want to do is additional transform offset to apply. So that's going to be export var transform offset transform 3D. And we're basically going to copy this, but then say our new, there we go. Because we want that skeleton update to be called at least once. What we're now going to do is, we don't have one, we're just going to apply our transform offset. If we are, we're going to go and do we multiply it after or before? I think we're going to do that before. So we're going to do that. So now, oh, we crashed. That hasn't happened to me for a long time. Okay. That makes sense because I hadn't reloaded the scene. So now I'm multiplying with a variable that doesn't exist in memory yet. Because when our node was loaded into memory, that variable wasn't added to this instance. So it was executing that and saying, that's a null. I'm going to multiply with a null transform, and yeah, it's not going to be happy with that. Hey, cat, you good? Yeah, there's still some bickies there. You can go and have those. All right. So with that, we do have a nice transfer offset. Why does it not give us? Oh, because we would need to implement that whole thing. That is such a shame that we don't have a nice UI for that. Okay. Let's make that nicer for us. And what we're actually going to do, let's be a little bit smarter this time and just close that while we make changes like this. We're going to break this off into two. One is going to be a position offset. That's now going to be a vector 3 position offset. Thanks for coming. And we're going to make a rotational offset. Let me just double check something. They're just call it rotation. So that's going to be rotation offset. All right, so that's, oops, that is that. Okay, cool. Actually, rotation offset, boom. All right, which means that it's now not happy about that not existing. We are going to have to go and create that one. That's going to be a transform 3D. That has to be var. Okay, that's going to be a basis, positional offset. And in this case, I believe that we can just do no, we want it from Euler. Is that a static function? Let's see if that is a static function. And that is the rotation. That should do the trick. Let's give these some proper default so that they don't accidentally become null. There we go. All right. So with that, All right. We should be able to rotate that. Very cool. And we should be able to offset that. Very cool. Now, obviously, we want that to be in degrees, just like a normal thing is. Now, normally we do that with hints. But if I recall correctly, if we do a range here, so let's see that is going to be minus pi, for instance, or maybe 0 to tau is actually better. But then it doesn't like that because that's a float. So we need to actually go and do that in our validate properties. So what we're going to do here is else if property.name is rotation offset, property.hint is property hint range, and then property hint string. That's going to be 0 to 0. I think I can write that out like this. And that is not a function, but that is like this. Okay. And that needs to have this in there. All right. Let's see if that works. Yes. Look at that. However, I don't like it like tau. So do I need to do it like this? Just to insert tau? I don't know if 5 decimals is enough, but let's see if that works. Nope, doesn't seem to work. Oh, but also this is, oh, right. I remember now. Because we go radians in degrees, I actually need to set this in degrees as well. I think. That's better. So now we go to 360 and 0. Let's see if that indeed works correctly. Yep, 360 back to 0. So we now have that as offsets that we can control, which means we also have offsets here. And the nice thing about that is yeah. Now the problem, of course, is I can move this and that doesn't actually do anything. It moves it back into place because we are in control of the transform. Potentially, I could do something with that movement and translate it to our offset. But unfortunately, we're going to have to go and control that like this. All right. However, for the teleport, I want that position to be fixed. Now, again, here we should say suit position, our node. We can use our position offsets and position rotation offsets for this, but I want to do in. So we're going to go and say position offsets. Oh, that needs to be between quotes. And rotation offsets. We're going to go and hide those. One more bracket. I don't think we need these. Just do that. Oh, and that should not be brackets. That should be those ones. Oh. We're getting there. There we go. It's happy now. All right. With that, it should hide all those, which is exactly what we want, because we are going to have control over those. However, that means that now our position, we're not going to do anything with the rotate, but we are going to do something with our position. Excuse me. And actually, one of the things that might be interesting here. Now, let's go and do a helper node here. Marker 3D. All right, cool. I like the marker because if you don't have that selected, can we deselect, please? Yeah. You can still see the marker location here, which is pretty cool. Anyway, so we're going to want to have this point somewhere. Where are we going to have our... So that's the thing, right? Is we're going to want to have an origin point for our raycast. We don't want to raycast right on the hand. Or maybe we do. Do we want that just to be nicely in the palm, like somewhere over here? And when you look at, for instance, the circle, that's something that we do with the pickup here. I actually have this detection offset in here. And that's kind of what we're now trying to reproduce with this. So let's go and actually use that. Let's see, pickup then 0.03. And 0. So we are over there. All right. So it's on the same height. We just forward by 0.0, and then we're in by 0.03. But what we'll see if we look at the pickup on the right hand, that's actually minus. So on this, it's positive. On this one, it's minus. So that is something that I actually want to now embed into our teleport function here. So what we're going to do here now is we're going to say position offset is, so this is going to be 0.03. If that's else minus 0.03, 0, and this was minus 0.06, I believe. And again, the problem here is that those are the correct measurements, for our default hand. And potentially this is something that we do want to go and make settable. Even though I want to make sure that it is something that works between the two. We're going to reopen this again to actually make that work. So yeah, that is now nicely positioned there. So our teleport is now properly there. And I kind of want to do the same with pickup. That we, no, actually with the pickup I can't. Because of the pickup, it needs to stay at this position, because else all our grab post logic doesn't work. But for a teleport, it's fine to have this actually from the point where we want our teleport to start working from. All right, so pretty happy with that. But yeah, as I was saying, this is the correct position for this hand mesh. Obviously, if we are using a different hand mesh, we might have a different offset that we need to do. So I'm actually going to add a to-do here. Position offset is correct for our default hand mesh. May needs we allow alternative, which is already possible. That's already supported by extra tools. And then the same with sort of the controller. So what we're eventually going to be doing here, and again, I don't have this logic in extra tools 2 yet. I do have this logic in extra tools 1, where we apply an offset based on whether we are using the grip pose or whether we're using the aim pose or whether we're using the palm pose, because they all have different orientations. Because right now we're assuming that palm pose is supported and we're always using the palm pose. The palm pose is actually already there. So But again, I'm kind of working on the assumption that people who are using XR-Tools 2 will always be using the XR controller hand. Although I guess that in a situation where you're doing MR stuff, that might not apply. But then teleport won't work either, and pickup will have limited functionality anyway. So yeah, that is definitely something where improvement is still needed. Anyway, yeah, I'm happy with this so far. We'll eventually, if we have a use case, we have a scenario where we're actually using the XR controller, we can start implementing more functionality there. For now, I'm just going to, just in case, I'm just going to go and reset that, and I'm going to add that after these comments, just to be clear that that is what we're doing. All right, sweet. Okay, so now we have the positioning of our teleport function on our hand correct. We are using our hand attachment. So now suddenly this is a lot better than it was before. Excuse me. So I'm pretty happy with those changes. And eventually I'll apply that to XR2 pickup as well. I think that makes a lot of sense. Cool, Miguel. I am happy with that, actually. Yeah, sweet. So now we need to go and start making the teleport function itself work. And for that, we need to start adding some stuff to the pickup function. And figure out what the nicest way is to make that work. And we're going to start with a Raycast to figure out where actually are we going to teleport to. All right. So we've got our enter tree here. Do we need to do a exit tree? I think so. Exit tree. We obviously need to call super there, but we're going to call super at the end. And all that I want to do here is make sure that this is null. So we're not dealing with that. All right, cool. Let's go and also add a ready function here. And I am going to call super on that. I don't know if there is a ready function in here. I think so. No, we don't, but I'm going to leave that. Oh, okay. So it doesn't even like that, even though there might be a ready function in Node 3D or anything like that. Yeah, nothing important, I think. Okay, let me think out loud here. So yeah, let's go. Actually, let's also start with already starting some code regions here, just so that we have that. Private variables. Yeah, the code region is probably very overkill for what we're doing here, but private functions. We are going to have, oops, we're going to have more things in a minute. Raycast. Right. So, in our ready function here, and I am going to do this even in the editor, I think. And this is the one thing that I'm not quite sure I like. So we create a new Raycast, and we add our Raycast. Oops. As an internal node. So again, I would have to go and do this. Even though we now have that Raycast object created, we don't actually see it. If I would add a Raycast here, can I type? Thank you. we have our gizmo drawn for our raycast. But because that is not part of the teleport node, we actually don't see that. So there is a big question. Does it make sense to even execute this? So what we can do, engine is editor hint, and we can say this is not an editor. No need to run this in runtime. Oops, sorry, the other way around. No need to run this in the editor. So we're only going to set up our extra nodes if we are inside of runtime. In the editor, there's no point in adding these things. They don't do anything. And that also means that we can now check on the existence of our Raycast node for the rest of our logic. Because if we aren't, if we are in the editor, the Raycast node is never created. So there's no point in running our physics process or our normal process or whatever, in this case, we want to use for this. Obviously, we can put in some things here or even in here to do some editor visualization. Although there too, I'm sort of going like, hey, I'm doing it in a couple of other places where we are creating things for visualization. So for instance, well, like this circle here for our pickup detection range, that actually needs to move to a gizmo for our pickup function. So that's another reason why I wanted to make that why I wanted to make the XR Tools helper script just an XR Tools script, because eventually that becomes our plugin. And as part of the plugin script, I want to start adding gizmo logic to a lot of these nodes, these new types. Okay. So we do have our Raycast created. We know that it points downwards. Actually, let me add in my Raycast again. The reason why is because I want to have a look at this. So our target position is -1. So we really want something like this, that we point there. Now this is probably too sharp. So we're going to have an angle here. And we're going to have a length of how far are we going to detect our teleport. And we're going to have to find out what feels natural when teleporting. All right. The other thing here is, and I'm just going to leave this just for testing so that we can actually see what our things are. And in this case, we do want to say raycast.enabled. It's false. We're going to leave that disabled until we actually do our Raycast functionality, which actually also means I already want to start adding some teleport start, teleport canceled, and teleport done. Make that another code region, code signals. So these are just to allow us to do some control. And this is specifically, again, when we are not using our default objects. If we are going to use this in combination with just normal extra controller nodes, we might want additional logic. For our defaults, we're going to start looking at, okay, can we find our locomotion handler? Because in that case, we actually want our locomotion handler to be disabled. So yeah. Because while we're doing our teleport, we don't want to accidentally also move our character, because we're going to use the joystick for other things. Okie doke. But one step at a time. What is it, cat? Yeah. What is it, pussycat? What is it? Hello. Hello. Sorry, guys, my cat is asking for attention. She's being very sad I'm not playing with her. She hates it when I pick her up, so else I would pick her up and go, "Hello, here's my cat." But she hates it when I do that. Okay. Let's start with creating our physics process. Right. If not or not XR controller or not XR collision hand. In these cases, we can't do anything, so we are out of there. All right. So we're going to need a few export variables to control our excuse me, our teleport. Now, the first thing that I want to do is add an enable flag here so that we, and I've done that on all my things. So for instance, on turn movement, there is an enabled on our movement provider. Here, obviously, we now have it enabled on our teleport so that if there's a reason in logic that we want to disable the teleport and not, completely get rid of the whole thing, we can do so. So let's go and get that off. Now, one of the things that we might need to do here is if we already have a teleport in progress when we disable it, that we do some more, but we will deal with that when the time comes. If that is really something, then obviously we need to go and cancel our teleport function. All right. We also want to add a Raycast angle here. Let's put that to 20 degrees. That might need to be a vector rad. That's going to be a range 0 to 45. And let's go and copy that from here. And that is in radians as degrees. Oh yeah, that's a step value. Okay. Let's see if it does a sensible thing there. Yeah, 45. So that does need to be a degrees to radians. Hey, Bliggy. Did that not save? That did not save. Maybe. Oh, haha. So like the streaming. All right, there we go. That's working correctly now. So we have a Raycast angle. I'll add in. I will add in comments later on. So that's going to be a Raycast max distance. So that's how far the maximum that we point our Raycast at. And it kind of limits how far we will be able to teleport. All right, so in both these cases, I actually want setters. Raycast angle is value, so let's go as well. Boom. Now that's going to be Raycast max distance. There we go. And then here we're going to say if we have a Raycast, I'm going to do updates. Raycast. well. All right. And then obviously we need to define it as a function. All right. And in this case, what we want to manipulate, and I'm going to test it on this first, just so that we can see it work. Oh, how can we do that if I'm not doing this in? You good, Blake?
Yep.
The way that we're going to do that is by just doing visible collision shapes. It's going to be annoying, but that will allow us to see what we're doing with that raycast, because pretty sure that we're going to rotate that in the wrong direction. However, we have our raycast in our z direction. So what we're going to do here is raycast dot target position is vector 3 0 0 minus raycast max distance. And we're going to do that rotated that needs to be raycast angle. Now that could be that it now points upwards instead of down. We will see that quickly enough, and if it points the wrong way, that is easy to fix. All right. So obviously in this case, I'm going to make sure that as we have created our raycast here, is that obviously we also run that update there. Cool. I'm not sure if that is going to be displayed when the raycast is disabled. So I'm going to just set this to true just for now, just so that we can test. And I bet you that this one is going to sleep. Yes, of course it has. So let's go and Ooh, okay. I am going to need to charge my controller soon. That is not surprising. All right. Yeah, yep, that's loaded now. All right, cool. Let's see. Oh, of course, we now have two raycasts because I also have our default one. Now the red one, or the one that's currently red because it's colliding with something, that's the one that we added by default. But the one, the blue one, as you can see, that's slightly pointed upwards. That's actually the one that we are creating behind the scenes. And I know that because the one that we added here, this one is pointed down properly. So let's go and remove that now that we no longer need that one. And let's go here. And what we simply need to do is in our function here is just make that negative. That should rotate it the right way around. All right. All right, so that's, yeah, that is pointing right, but it's not actually colliding with the ground, which is what I would like. It is colliding with that, and that's of course very logical because I made the ground sit in what you call it? What's the right name? Sorry, guys, I am having a brain malfunction here. My hand is funny. Yeah, no, I put my ground into a different collision layer. That's what I'm thinking about. I'm getting a bit tired. Okay. And that's why it's not colliding. But that also reminds me that we want to have an actual collision mask on our raycast here. So let's go and create our region here now. Right, and this is going to be our export variables. Yay. So we've got enabled, we got that, we got that. I'm going to actually put that over here. Export 3D physics bar collision mask. That's an int. Can we do it like this? I think so. All right. All right, cool. I think we probably, well, the first 16? Why only the first 16? That should already be 16. That should be, yeah, whatever. As long as the first couple of masks are selected, I'm actually kind of happy. All right, so in this case, same thing, value, collision mask is value. And we're just going to go and do that. In runtime, these things should never really change. So we really should only be calling that once. But, you know, we're just being overly careful here, which means that I should be able to set the collision mask here to our collision mask. If I do that, I should now be able to hit the ground. Right, so cool. So now, yeah, we can collide with the ground. I think our 2 meters that we set is probably way too little. Look at all the nice collision shapes on my head. So you probably want to teleport a bit further than that. The other thing that I'm thinking of is when we move like this, we have our raycast go sideways. And I really just want the raycast to always be pointing to the ground. All right. Yeah. Oh, sorry. All right. So. Now, the easiest way to solve that is to lock the orientation of our raycast to the orientation of our origin node. So I want to go and grab that one. All right. Which means that we should be able, in our enter tree here, to say origin is xrd2 get xr origin. There we go. Self. That means on our exit tree, we want to have that as null. Cool. And then here, we're going to want to we're going to want to match orientation of our raycast to our origin. If and raycast I might actually want to do that before this, just to make life nicer. Okay. this case, we want to say Raycast global bases is our origin dot global. Cool. So remember, we are positioning our teleport node, but our Raycast node is a child. So we can reorientate that any way we want. And seeing that we're just going to execute the Raycast in our physics process here, even if the orientation changes afterwards, we're in pretty good shape. Alrighty. Let's see if that now makes sense. So now we can see that no matter how I move my hand, the Raycast is always pointing down. But that is not really what I want, because I really only want to get rid of that. I still want to be able to go up, down to define how far I'm going. So I just want to get the tilt out. How to do that? So we just want to remove the tilt. Which means that we want to take the Z direction of our origin node. No, of our... Because do we want to be able to do that? Do we just want to take that out? I think so. So I think if we take our... Okay. I need my origin basis is origin global basis dot inverse. So now we have, yeah, we have that. So now what we can do, yeah, we're gonna get there eventually. I hope I get there today. I might need to continue the stream tomorrow because it's almost dinner time here. But we will see. We're gonna go and let's go that forward. What I want to do here is Raycast dot global basis dot Z. But now I want to. This is just a basis. That's great because I don't care about position. So now we have a forward vector. And that means I should be able to say, looking at forward. And that should remove the tilt. So this is going to calculate that in the orientation. And the reason why I'm doing this is in case our player, let's say that we do a Mario Galaxy style game where we're going to walk around, what you call it? Walk around a sphere, we might not be upright. So we need to calculate what this is going to be within the orientation of our origin, in which case we're, in local space horizontal. And then we are multiplying that with our origin's global basis to actually get the correct orientation. I could go all the way back to the character, but because origin is always in the same orientation, just in a different location, but always in the same orientation as our character body, this is fine. This should just work. All right. And one thing that I find important with this sort of things is to test often to make sure that it now does something sensible. All right, so, it's okay. What is it doing now? Oh, that is because the forward, I hate it when it does that. Excuse me. And I still think that it's probably, yeah, we're going to have to do a little bit more here, but that's okay. So this is going to be vector 3 dot up, but now, true. I don't have enough room here. You cleaning up, Leggy?
Yep.
Smart. Yep, so that should mean that that's good. But the other thing that I think I need to do is take the X part out of there. All right. No, that would go wrong. That would remove too much. Okay, let's see if whether, because I did that wrong with that, that explains why I'm not having, I'm not seeing what I'm thinking or was expecting to see. Because I can move that, but yeah, I don't get, because that's what I wanted, right? If I turn like this, it's still pointing down. It's purely when I move up and down like that, that allows me to make it go further and less. I can go that, I can go that. Perfect. All right. That is really what we want. Now, the other thing that we may want to do, which is really nice that we have it as a, I'm wondering, ooh, that would actually be really cool to do. I'm thinking if we make the Raycast top level, so that we are positioning and orientating it the way we want. That way, we can actually lerp it. We can make it a little bit more stable and not so shaky. Anyway, one step at a time. So basically, instead of assigning this, we're going to lerp it. Okay. And that requires us to do add child, blah, blah, blah. Very good. And then Raycast, top level, true. So that means that we are positioning it separate from I'd like to see a function that stops a player from falling off edges. Oh yeah, that is actually relatively simple to do. When we are looking at the logic that we have for movement, so that would be then something I would implement in something like our locomotion. Is yeah, you would do a raycast, and you would basically say, okay, if I suddenly, you would just put a raycast in front of the player pointing down, and if suddenly there's nothing there, is you would stop the movement. That does mean that you can't jump off this if you actually want to. So you want to have some way to allow it. But yeah, that's maybe a nice one to do at some point. But it wouldn't be too hard to implement. And if you obviously also want to be able to not strafe off of the platform or back off of a platform, you can do that. And you can allow a minimum height. Like we do want to be able to walk down the stairs here, but you can say like, okay, if there is more than a 10 centimeter drop or a 30 centimeter drop or whatever, stop the movement. If it's less, then yeah, you're allowed to fall down, quote unquote fall down. That might be something to keep in mind when I fix the bobbing issue. bit of oscillation that we currently have when you're moving around. All right, cool. No, I got the Steam frame from Valve specifically to test Godot working with the frame. So yeah, I got lucky there, and that actually goes for many of the headsets that I have. Most are provided by the different vendors to us, not just me, other developers in Godot ecosystem as well. They are provided to us to do testing and make sure that things work properly. So that's always nice to have that support from companies like Valve and Meta and Pico and Google and others. So yeah. Let me think here. So yeah, what I wanted to start doing. So the other thing, obviously, that I need to do here now is Raycast dot global position. And right now, it actually doesn't matter whether it's global position or position. So I probably just want to make that basis and position is in this case going to be the same as our global position. So let's test that. That should now work exactly the same. We're just testing whether this logic does what it's supposed to do. Yep, so we can see that that is still going fine. Actually, it's already more stable now, which is really nice. Okay, but that is no longer working. So why is the up-down no longer working? Oh, because I'm now getting the Raycast global basis, and I actually want to do that from our hand node. Okay. Yeah. So now it moves along again. Up, down is fine. But again, I'm very shaky in my hands. Oh no. And I kind of want to damp that a little bit. Obviously, I also want our default length, and I might actually want our default angle to be a bit more. Also, if you will implement something like teleport anchors that could snap the specific teleport zones easily, yes, it's definitely something that I want to do as part of this. So yeah, and as far as the shadows is concerned, that is a matter of setting up things like your light properly. So when you go and look at your light here, you have these properties. So the default properties here affect, actually this is the first of two things that you need to look at. So the properties here says how far do my shadows actually reach. So as you can see, my shadows fade out after 30 meters from where the camera is, or the further I go, the more the shadows go out. The further your shadow distance is, the lower the quality of your shadows will be, because it needs to, the shadow maps need to cover a wider area. The other things are these split numbers. So basically you have 4 levels of shadows, and you can actually visualize that by going to advanced here, and you can see your directional shadow map. Is it direct? Yeah, I think it's the directional one. Yeah, so here you can see the 4 levels of shadows. This being used for close shadows, this being used for slightly further away, and these are the furthest away. So this is basically our 30-meter shadow map. And this is the other thing that you can see if you zoom in a little bit. So actually do that. That's this. Can we see that properly here? Trying to find an example here that shows, but it doesn't show as easily as in the headset. But actually we can change to this other mode here, which is directional shadow splits. There we go. So here you can see those colors. So red was the closest, then green, blue, and then in the distance here you see yellow. So this is where you see, like, this is our first split. So those are the closest and most high resolution shadows. This is then one down, furthest. Excuse me, my throat is getting a bit dry. So this, by the way, is again something to be aware of. You have those options to visualize that, and it allows you to sort of fine tune things. So if I, for instance, make this, let's say I make that 7, you'll see that the red now goes further. Now, on one side, that means that my highest detail shadow maps now reach further, but it also means that my higher shadow, my lowest detail shadow map, or my closest shadow map, now expands a larger area, and therefore the detail is going to be less. So that's the first thing to know about. The second thing to know about is if you go into your project settings, is that you have here the size of your directional shadow map. And the defaults of these are very, very conservative. So you'll see that I've actually doubled them, both on mobile and on PC. But depending on how fast your computer is, you can actually up these more and more and more. Now, these are the defaults for your viewport. You can override those in runtime as well. They are properties on the viewport. But yeah, really, at this point, it really depends on, okay, how fast is your computer? Like, I can even double these, and that would, make the shadows even crisper. But obviously, you're going to want to do something that that is a good setting for your hardware. But it's all about playing around with the shadows and finding out what works, what looks best. So. And actually, that reminds me that because I'm using the spectator view and I'm in here, I suddenly realize I am probably not using the best ones. I thought these were per viewport. Maybe they are global. I think it might be global. Yeah, I think they're global. So it's probably reusing the shadow map there. Anyway, something to be aware of. That you can control those. Anyway, playing around with those settings, and you can create really decent looking shadows in your game. Also, keep in mind, if you obviously increase the resolution of your shadow map, that does come with a performance penalty. The bigger they are, the more memory they take in, and the more overhead it is in actually rendering the shadows. And the directional shadows are rendered every frame. So all those 4 maps are always being updated. This is just power. Because these streams go on for a number of hours, I would eventually run out of battery. So I always have it plugged into power, and that's all. The actual connection to the PC is wireless. But yeah, it's just purely power. Okay, where were we? So yeah, so the thing that I wanted to create with this, and the reason why I wanted to not have those together. Oh, first I wanted to change the defaults here. I'm actually going to make that up to 10, and I'm going to double the range of our Raycast here. Yeah, I can imagine that the original Extra Tools is having more difficulty with that. I actually haven't implemented jump in this yet, although it shouldn't be hard to add that in. But you can see that I, for instance, have stairs logic. The big difference with Extra Tools 2 compared to Extra Tools 1 is Extra Tools 1 has a full length collision shape, so you're actually colliding with the ground. And that is often making it hard to sort of get up ramps, even with jumping. Extra Tools 2 has got a capture shape just for the body, and we have a Raycast that controls the height of the body, which means that I can actually go up these stairs and it will move up. And it should also be working a lot easier for jumping. Sorry, Cat, I just nudged you there. So yeah, that should definitely work a lot better in Extra Tools 2 than it did in Extra Tools 1. Okay, so I've doubled that. I do need to double check if that holds here. Oh, look at that. That was not even set, so that's interesting. Maybe the distance was never good at all to begin with. Maybe now we've made it way too big. No, that's a decent. Okay, so the other thing that I wonder about is, do I want that to be a sharper angle or not? Yeah, I do think I want that to be a sharper angle. So we're also going to go and increase this default angle. Let's actually make the maximum here a little bit more crazy in case someone wants to do something like that. Alrighty. All right, so yeah, that looks much better. So now the question is, do I want to stabilize this a bit? I think I do. We're going to add in a lerp for that. So that was the whole reason that I wanted to do this. Is we're going to go and say lerp from to, and let's just make that now 4 frames in this case is fine. Now we also want to lerp this one. However, that needs to be first of all, that needs to be a slurp. And that is actually a value there. All right. Yes, I find it very comfortable with my glasses, but I have to emphasize my glasses. I have fairly slim glasses, so depending on what sort of glasses you wear, your mileage may vary. So I can't comment on how it would be for other people. But for me, I find it very nice. Also, I like wearing the headset on my head if I know that I'm going to put it back on, and it's really comfortable and easy to do that. It's actually one of the things that I really like. If I wasn't using this as a development headset, I would want to use lens inserts and take my glasses off and do that. But I've found personally, as a developer, because you're constantly taking your headset on and off, having to also take your glasses on and off when you're switching, because I still need my glasses in order to read my computer screen. I find that very irritating. I actually did buy lens inserts for my index, and I took them out for that reason. But again, if I would go for a play session, if I actually would be playing a game and I would be wearing the headset for a prolonged amount of time, I do admit that having lens inserts is more comfortable. But so far, I have found that that for my glasses and my face, wearing glasses for the frame is fine. But again, personal experience might not be the same. All right. So, why is I'm getting errors. That's not good. Why am I getting errors? Why does it look like that? Bloody hell. Okay. Sure. You would think that that when you're doing a looking at, well, it's probably because I'm multiplying it with the global. This is a really annoying error, because in this case it's just floating point errors that are causing them to be slightly off. Yeah, the end result here is that it's actually, what do you want to call it? That basis would be possible for it to actually do the logic that it needs to do. But yeah, we now do a nice little slurp. Now, one of the other things that's really interesting there is that it was complaining about quaternions. We could probably make this logic much more efficient by actually using quaternions. However, the point is, twisting my hand like this now is fine and working the way that I wanted. You can probably notice that there's a little bit of a lag in the Raycast now, but that is what I wanted to do with that slurp. Obviously, once we actually make this work, we're not going to be showing the debug Raycast. I'm just doing that to visualize the Raycast net right now to get this to work properly. But yeah, cool. So yeah, that just means it's a little bit stable. It doesn't vibrate so much. Oh, look at how much that goes. That's because I'm moving right now. But again, we're not going to actually be visualizing that. And that probably is something where we might want to make sure that the physics process of our teleport is running later. All right, let's have a look. Because we want to really have that run after our collision hand is positioned. That is probably ran in the background here. Here we go. Process physics is -90. Over teleport. Did I do it in ready? I did. In teleport, we might want to just put that on 91. That should fix that, I think. Maybe the other way around. I always forget whether lower is better, or lower means that it's later, or lower means that it's more early. Okay. Maybe that is purely the lerp that is actually causing this. Yeah, I think it's just because the lerp is. So is it a good idea to do the lerp thing? So I would be expecting this physics process to be handled after the physics process of the hand, because there's a child node. So, all right. Let's try that the other way around. Oops. Because when yeah, that's much better. So it's purely because of the lerp. And again, maybe lerping is just overkill. But the important thing is, we want to have a stable place to point. And actually, come to think of it, because I don't actually care, I am actually going to do this, because the only thing that I care about is where the Raycast hits the ground. Because everything else we are going to do from the hand to there. And all that we're just trying to accomplish here is for it to not be jerky. So I think that will work fine. All right, let's see what is in chat. Is this going to be something like native class in Godot, or an add-on plugin you have to download in order to use? No, this is a plugin. This is a plugin called Extra Tools 2. And you will eventually be able to download it from the asset libs asset store. The original one you can already download. So if you search here for tools, Extra Tools, there you have it. That's the predecessor. So that one is fully functional, but it's getting a bit old. It's using some older techniques, but definitely something that's, if you want to build a VR game with Godot right now, definitely something that I recommend checking out, because it is fairly featured. It does most of the things that you would want to be able to do in a traditional VR game. But I'm just working on a brand new version that does things in a little bit more modern way. Think I'd be, yeah, it's an add-on. I don't have a VR headset, but I'm looking to get Steam Frame if it is not super expensive yet. Well, nobody knows the price yet, and we are living in a world right now where everything suddenly has skyrocketed in price. So, fingers crossed. I've tried in one of those arcades, the meta thing that was wireless. It was fun. Yeah, well, it really depends on what you've tried. Most of the arcades right now are still using Quest 2s, so that's already fairly old technology. When you, well, in perspective, I have a Quest 3 somewhere behind me. Don't know if it's on the left or right, which is a headset that I really enjoy, and that is really high quality. So yeah, definitely try one of those out and see if you like it. Those are, you know, those are fairly affordable secondhand and even new. So especially if you want to do PC VR stuff, they are more than enough. So so yeah, don't sleep on those. But yeah, I'm also very much a fan of these, and I am looking forward to seeing them out in the wild, and I hope people will enjoy them as much as I am. So anyway, yeah, you know, when and from what I know, from most of the arcades, they are running PC VR streaming. So the VR application will run on the PC, and what you see in the headset is just being streamed to the headset. So yeah, that's fairly high fidelity, and that really, really works. Okay. Cool. Cool. Where are we? So yeah, that is that. That's all good. I'm actually going to turn off that. We are now going to say the Raycast is not enabled right now. What I am going to do is create another little thing here. It's going to be called targets. It's going to be a mesh instance 3D. All right. So now we're going to go and create that. So let's put in create our Raycasts. Create our targets. Oops. Is mesh instance 3D dot new. We want to then also create a mesh. Let's make it half a meter by half a meter. That's probably too big, but yeah, we got to start with something. Target.mesh is mesh. Then add child's targets. Oops. There we go. So we do that, but now we do target.top level. This definitely needs to be top level. Also, we're going to hide this. All right, cool. All right, so this is going to be a mesh that we are going to be showing where our Raycast is hitting. All right, so
Clothes bin is gone.
Huh?
Clothes bin is gone.
Oh no, we got to go and drop that off somewhere else then. Well, at least you've already sorted it out. So, all right. So, let's go and make sure that we are only showing or hiding that if that makes sense. So we'll set that to true, obviously, when we do want to show it. So now we're going to go and have to do our Raycast logic. All right, cool. So we've got a controller here. We've got our XR hand there. So we want to go and All right, so we're only creating our controller. So I'm going to make this a little smarter. If controller, then null. Also, if XR collision hands, you can actually make an else if because the control. Let's be safe. Okay. Our inherited more to do. No. Okay. XR collision hands dot button pressed disconnects on button pressed. And now, yeah, no, those don't exist yet. On button released. Okay. We want to do the same over here. So if we have a collision hand, we are going to now connect to those. Okay. That's just going to have an action name. Perfect. But if we have a controller, I believe the signals are the same. Cool. So that means we can reuse these. But obviously, we want to do that. I think. Cool. And here we obviously need to go and also disconnect them. And now we can make those functions. And we'll put those at the bottom here. Pressed. And all right. Now, button release, action name. Cool. All righty. All right. Let's call it teleport. Oh, still not happy. Why not? Oh, yeah, that's not gonna work. All right, so this obviously we also want an export variable, and I actually want that at the top. Export var teleport action teleport. Cool. And then here, if name, then we're going to start our teleport, and here we're going to end our teleport. Okay, cool.
This is just full of old like computer stuff, like old controllers and mouses that I've just been leaving around. You want me to just throw it out, or you want to look through it?
If we haven't been using it for a long time, just chuck it away.
Yeah.
Okay. You suddenly got into spring cleaning, Blake.
Yep.
Okay. So when we start our action, we obviously want our Raycast to be enabled. And when we release, whoops, we want our Raycast to be disabled. But here we need to add, if we have a target, teleport, else cancel. Okay. Okay, let's see. I'm trying to learn as fast as I can. But how exactly are we transforming the player bases with the OpenXR touch controller action sets for basic movement? That is a very long story to answer just on stream right now. I have a series of videos. Hold on for a second. That I really recommend you to watch. So if you go and look at my videos, I fairly recently did this series, starting here with XR first person controller, all the way through to, so that's part 3, and I think that's a part 4. No, that's part 3 is the last one, because yeah, the 4th one was the spectator view. So these 3 videos will give you an entire story of how you can build a first-person controller for XR, which includes movement, both physical movement through your room as well as handling the controller input and moving it around. Obviously, there's no teleport in here because I'm only now building the teleport. But yeah, highly recommend having a look at that. All right. So we have a target, we teleport, else we cancel teleports. Obviously, we're going to be implementing that later. For now, we're going to say, okay, we're going to enable our Raycast here. Now, in this case, I really should also check if our enabled flag is set. Where are you? Over here. However, that gives me a problem that I would then also need to track whether we, in the weird situation where you would press the button and while the button is pressed, someone would enable the teleport logic. Probably overthinking that one. For now, I am just going to enable the Raycast, but obviously because in this logic, when enabled, we're already exiting. And we probably, if we are in the process of doing a teleport, we might want to cancel at that point. Yeah, maybe we should. Actually, let's call that enabled. All right, which means then here, I actually really want to set that enabled is value. There we go. All right. Are in teleport started. That's false. All right. In this case, okay. True. That's false. All right. So that's and probably if enabled teleport started.init. Okay. Cool. Here, I want to say if enabled, this is value. We just return because there's nothing more to do here. And here we say if enabled, Raycast enabled is true. Oh no, is teleport. Actually, I don't want to call that teleport started. I want to call that teleport active. Active and active. The other thing that I really want to do is actually create functions that says, excuse me, the noise in the background. Func teleports started. I don't know if there is additional stuff that we need to do here. But we're gonna do, oops, we're gonna do that, teleport start, and I actually think that I want to put that in here. All right, so we're gonna enable the Raycast. We're gonna emit the signal, and potentially we have additional things that we will do there. And obviously we're gonna have a teleport, whoops, teleport cancel. So we're going to do that true. We're going to do this false. Okay, that's going to go there. So here, if this is true, just to have something here, teleport. What did I call it? Let's see. Okay, maybe we do food teleport. Else cancel teleport. Teleport canceled. All right, cool. Yep, I know, because we haven't defined that yet. Okay. For teleport. No, that's dot emit. There we go. It's gonna be to-do teleports. And in this case, we want to make sure that our target visible is false. So make sure that we had a teleport our target when we're finished. So that means that over here we say if enables. Cool. If we also have teleport active, actually no, we're going to do that the other way around. If teleport active, then if enabled, then we do teleport start, else teleport cancel. So in this case, when we enable our function and our button is already pressed, we start our teleport. If we enable or disable it and our teleport is active, we obviously cancel. But the teleport active is just the button status, nothing else. And maybe I need to even, you know what? Maybe I even need to rename that, because that is way too. Okay, what if I just do teleport pressed? I think that is. Activates pressed. I think that is probably a better name for this. There we go. There we go. And there we go. Cool. All right. So now we have everything already being controlled by all of that. So here we just have additional logic, and here we only get here if it's enabled, if our that needs to be an or. Okay, so here we just make sure that's positioned regardless of what we're doing, and that's because even though if we've got things disabled, we want to do that slurp, or else suddenly when we enable or press our button, then suddenly our Raycast is just jumped into position. If we don't have any of these things, we return. If we do have those things, okay, then we can purely work on the basis of our Raycast is colliding. We have a target. All right. So now we want to do, we want to check if we can actually use that. So for that, we need to go and have a look at our Raycast object. Collide that, see what I will close. That's it. Here we go. So we want to get our collider normal. Because if we're colliding with a wall, if you point to a wall, we don't suddenly want to step onto a wall. We want to make sure that we're colliding with a actually we want both of these. But let's start with the normal. So we are colliding with something. So normal is Raycast dot get colliding normal. Let's actually give that a type. So what we now want to do is we want to compare our angle. We don't care about sine, we just care about angle 2. And the vector that we want here, we can actually check on our XR origin dot global basis dot y. And we need to check if that angle is smaller than a certain amount. Are you okay, Blake?
With the bed sheet and stuff.
I have to check for you after I'm done. I can't do that right now. All right, returns the unsigned minimum angle to the given vector in radians. So I am, I'm actually going to hard code that for now. Let's say that we want to stick within 10 degrees. So we're going to see if the surface that we are colliding with is, upright to what our player is, so that we don't suddenly teleport our player onto a wall or upside down or anything like that. So in the case that that is good, we can go and get our position. Okay, we get our collision point. Cool. In this case, we're just going to position our target there. Okay, so that we at least can see it. And obviously our target visible in this case is going to be true. Okie dokie. Now we still need to deal with the orientation. Because especially, I don't think about the situation that we're on a big sphere. And that's why we do need to make this value settable. We'll add an export variable for that in a bit. And obviously, when we teleport, we want to make sure that our character actually gets in that orientation. But yeah, so one of the things that obviously is important right now is that we are colliding with anything. So in theory, we could even teleport on top of a box that is a rigid body. But we can eventually do something with physics layers to make restrictions there. All right. The other thing is obviously, again, I need to also adjust the global basis of the target. We actually will put a to-do for that here. Just global basis. But we also will want to introduce an offset there, a rotational offset. But one step at a time. I actually want to get to a point where we can show the target appearing in the right place. And after that, I'm going to have dinner. And then we'll pick this up tomorrow, most likely. So let's see how far we get now, because eventually I want to make this go a little bit up. Because this is going to have Z fighting with the floor. Maybe you need to do that right away. I think I'm going to do that right away. Plus targets, and I'm going to assume that our bases will be adjusted accordingly. So it's going to be global basis dot y times. Let's make that 1 centimeter. We're going to hover it 1 centimeter above whatever we are pointing at. All right. All right, cool. So, all right, now either our button isn't working, and obviously this is the other thing I need to do. I'm pressing the button right now so that we will be doing it, but I can still move. So that's another thing that I need to do, is when we start, I'm actually going to put a to-do in there for that. So over here, teleport start is to-do disable movement providers, and here to re-enable movement providers, and we want that here as well. That's just to remember that we need to do that. Okie dokie. Now, let's do some prints here to see if the whole logic doesn't work, or so that did work. Let's see if there is actually something that ends up in here. All right. Okay, I'm not seeing anything in my log. Not seeing anything here either. Oh, we have teleport started, teleport canceled. So why was my log not going up, or was it just not visible very well? Anyway, so we do have that. So our Raycast would have been enabled. Okay, let's go and keep that on so that we can actually see what's happening here. Okay. All right, there we go. We have that one. All right, so that is all working. It is colliding with the floor, but we don't have that. Oh yeah, it is. I can see the logs. It wasn't bright enough. Okay. So we're actually getting our raycast. So that might mean that our normal check isn't working. All right. Let's go and do a print of these and see if that makes sense. Oh. Don't fall on the ground, please. I should have that. All right. Okay, I'm not even getting there. Oh, I know what's going on. Oh, I am being very silly. So I'm checking here for both controller and collision hand, but only one of those is set. However, because of the way that we're working with binding our values here, we need neither. So all we need to do is check those two. we don't actually need to check the other ones. Alrighty. Okay. So now we can see that our target is nicely positioned. Now, I'm still having my rotation, obviously, because I haven't done anything with that. We probably need to do some more things because I was just hitting my body and getting it on my body. That's obviously not working. So here we can see that we don't get it if we hit a wall, and also, or I can't go that far. So if we go here, then I cannot hit that wall. And actually what I suddenly realized is that I only want to disable the movement providers on the hand that I am on. So we can make something nice out of that. I really want to disable that first because that's so annoying. So let's do that. Then I am going to have dinner. So I no longer need that print here. The other thing that I can do here is target is visible. Then I know that I have a target. And we're going to go teleport to that target. So the target is always going to be positioned where we want to teleport to, keeping in mind that little bit, obviously. But yeah, we'll eventually get that proper. Actually, remove that and say to do a maximum angle configurable. Or that's something that I need to do. That, and yeah, we're gonna go and deal with the movement providers. All right. So the way that we're going to do that is we're gonna do a enabled movement providers. It'll be an array. All right, movement providers. Boink. All right, cool. So now here, what we're going to do is var movement providers is get parent. We're always going to assume that that's an parent. Find children. The pattern here is going to be star, I believe, but the type then needs to be. That should give us all the movement providers that are on our hand. For movement provider in, but that doesn't need to have an underscore because this is a local variable. All right, if movement provider enabled. Why is, oh, because I don't have that here. So you'll be able to cast that. Now that does work. So if we have an enabled movement provider, we are going to add that here. Movement provider. And we're going to say movement provider enabled false. And now we're going to do enable movement providers. Definitely going to go and put that here. All right, and here it is enable movement providers. Oops, here. Yep. All right, so in here, what we're going to do is a for movement provider in that movement provider dot enabled true, and we're gonna say here. And that's really the only reason why we're doing that. It's just in case somehow we restart without first canceling. that we get that. All right. So, all righty. Cool. All right. So now when I do this, I can no longer turn. I can still move because that's my other hand. I can no longer use the movement provider on here. Oh. All right. It's easy to let go of the thing. Now, there's two things that I want to do here. One is that I also want to orient my target to my player, but also now I want to be able to rotate that based on my joystick, and then in that way control where I end up. All right. There's some more things that we need to do to make sure that we don't collide. I'm actually, oh no, that's an automatic exception with the parent, so that is cool. Oh yeah, bring up these. So yeah, we will be able to do that. But yeah, there's a couple of times when we see that the can't really reproduce it very well, but it was looking like the Raycast from time to time was getting in the way of my player buddy. So we obviously also need to go and find all our parents and add them to our exclusions. All right. But yeah, I'm pretty happy about this. We have our Raycast. We are now showing our target. Now the next thing is obviously, you know, in actually I'll do that too. I'm not convinced yet whether I actually like the having to press down on that. Maybe I'm going to switch back to using the trigger or something else. Oh, that's the wrong one. Here we go. Because I don't think I actually like that as a trigger point. The other option that I was thinking about is actually if we move that forward, that is going to trigger it. Yeah, now we can see we can go nicely position that. Yeah, that's really cool. So yeah, the next thing is we need to have a ribbon going from my hand to the target. And that is now going to not be, you know, what we with our Raycast. That's actually going to be from the hand nicely to the target. Our target is now nicely stabilized because of our lerp. Yeah, we can really see that. Yeah, sometimes it's colliding with something else. I'm not quite sure what it is. I think I'm sometimes colliding with my hand itself. Anyway, we need to make sure that on the Ray, and actually that makes sense because that. No, that is my rigid body. So, oh, because this is the parent. All right, all right, all right. That makes actually perfect sense. Let's go and actually implement that part. Okay, one more thing, and then I'm going to finally have dinner. Okay, so what I want to do right now is I want to go our parents node is get parents. Wow, parents. Okay, that is not there. Parent is parent dot parents. Yeah. What I want to do here is if parents dot is collision object 3D. I think that is the one that I need to check. Let me double check that. Or is it the parent class of this? Okay, physics body, is it physics body? Yes, physics body. Physics body 3D, then XR2 dot add collision extension between self and our parents. Oh, that is Raycast. headsets. Okay, and that means that we can't do that here. We need to do that in our ready function. Oh, I actually need to always do that. Okay, so let's get a helper function from that and say find add collision exceptions. All right, so this is going to be. Oh no, I can't do it like that. Oh, that is on the Raycast itself. I have a. What's that? No, remove. Add exception. Yep. It's actually collision. Okay. Hold on. We can do that. Here we're going to say if not Raycast. Turn. The nice thing is because this is on the Raycast object, when the Raycast object goes out of so this is going to be collision Q3 after all. Now that becomes Raycast add exception with parents. So we are setting this, and that also means that here on the Raycast we want to do clear exceptions. All right. So we're adding these on the Raycast, and then obviously when our Raycast goes out of scope, that will nicely be clear. We don't have to do a remove. Now, again, here we need to do this both on our enter tree. Now, in this case, the first time that this gets called, it does nothing. We don't have our Raycast object yet. Instead, the one that we're going to do here will do the necessary thing. However, if we would do our hand switch, we would be executing this again, and we would need to set different collision exceptions. So just want to have a quick look whether this indeed feels better. Whether we no longer get those weird things. There we go. So that works. No. I don't really get the feeling that it is colliding with things that it shouldn't be colliding with. I'm actually surprised that I can't get it to. Can I teleport on my hand? In theory, I should be able to teleport on my hand. So yeah, not sure about that. But yeah, I'm quite happy with how that works. So it might need to be perfected a little bit more. But yeah, fine, cool, sweet. All right. Let's see, Bastian, any updates on running Godot on the headset for faster iteration developer loops? Well, right now with this headset, obviously I'm running in PCVR mode, so I am happy with the iteration speed there. As you can see with me streaming this, there is really no delay in running the application. It's pretty much instantaneously. When you're obviously looking at a standalone headset, I still recommend that for normal development, you would stream. You would still run in PCVR mode like I do right now, and just streaming it to the headset like I do right now, and then only testing on headset when you really need to. For the headsets that support standalone development. However, obviously, if you want to do everything on the headset, you can use the Godot XR editor. You can run Godot on the headset as is. We have had that functionality for a long time now on the Godot on the Quest 3, and it even works on the Quest 2. So you can just install Godot on the Quest and then run Godot on the Quest itself, which means that it's, again, everything is pretty much instantaneously. You don't have the upload of your application to the headset. There is obviously a performance penalty for doing that. But yeah, it is. I'm fairly happy with how that works, and there's a couple of people now who have been very successful with running Godot in that way and doing projects completely on the headset. So yeah, but again, it really depends on what headset you're using and what your development environment is. Again, for me, just developing in PCVR mode, is great, and especially with a headset like the Frame that is very easy to take on and off. I don't really have a problem with with any sort of slowdown because of iterating testing. So yeah, but then again, that is definitely something where that varies from person to person. It really depends on what you're working on and what you prefer. It also depends on what operating system you're on. Obviously, on Windows, you have all the streaming options available. If you are working on Linux, you can get pretty far with ALVR or Wyvern. But I don't have that any personal experience with that, but it does the same as what we're doing here. If you are on a Mac, then the PCVR option does get very difficult. There are currently efforts being made to create streaming clients for Mac, seeing that Mac does now support OpenXR, or I should say OpenXR now supports Macs. So yeah. Hey, Lackluster Phones, how are you going? Yes, I did talk in the past about. Let me get some water. My throat is killing me at the moment. But yeah, I did talk in the past about moving extra tools into GD extension. Right now, I haven't done so yet. There isn't much to gain performance-wise. We are not writing any performance-critical code in the stuff that we're doing with extra tools. However, there are advantages to using GD extension, especially in the way that it encapsulates everything. So there, especially in Extra Tools 1, there were a lot of scenarios where you could accidentally set up things wrong because you use the script instead of the scene, and get into all sorts of trouble. And by moving things into GD extension, we could prevent a lot of that. Although the way that I'm doing things in Extra Tools 2, the likelihood of that is lower as well. My main concern and my main reason for sticking with GD script is the moment that I port Extra Tools to GD extension, I lose a lot of people who would be willing to help out. It is hard enough to learn a new language. It's hard enough to learn a new environment. If you then also suddenly need to dive deep into the internals of the engine and do everything in C++, not everybody in the community would be able to do stuff. So keeping this as GD script means that there are a lot of people within the XR community who will be able to look at code and help find problems and help resolve problems and just review everything. And we lose that the moment that you go to GD extension. That said, I am still tempted to do it someday. I can see the advantages of doing it. But yeah, at this point in time, I don't have any plans to actually do that. It's a thought. It's something that I am contemplating maybe some point. And it will likely depend on whether we really run into performance issues. All right, dinner time for me, everybody. So I hope this was interesting. I hope you guys learned something. Obviously, we're not done. I think we're about a third of the way, but this is the thing that I want to work on for most of the rest of the week. So I might pick this up sometime tomorrow, depending on meetings and things that I have. So yeah. Yeah, Extra Tools 2 is addressing the sort of mistakes that people are making. So specifically, the situation that whenever you give a class name to a script, so what we do here, like class name teleport, that means that if I select the node, I can go to plus here, and I can find it in my list, and I can add it. Now, Extra Tools is built in a way to support that and to say, like, yeah, that is the way that you should do this. But if you do that in Extra Tools 1, the reason that we give something a class name is not just so that we added to that plus menu, the main reason for giving something a class name is that we can refer to that logic, especially when things work together, when different nodes need to work together. Classing them, giving them a proper class name allows you to write cleaner code. But in XRTools 1, a lot of situations, this script only works if you use it together with a scene that is properly set up. And if you just add the node without the scene, the logic breaks. And that is something, like I said, in XRTools 2, I am avoiding that by the stuff that you've seen me do today. So I am creating my Raycast object in my ready function here. I am creating my target instance mesh here, and I'll be creating additional things. So everything that I need, instead of getting that from the scene that is added, and you would do that with that button over here, instead of doing that, you are doing it through through code, and that sort of safeguards people from making that mistake. But it's a lot of extra work on my part. I need to suddenly write code to add child nodes. And again, if I would port this to GD extension, I would have to do the same thing. There, you will always have to do that. There's issue there. Now, sometimes you can't avoid it. There are scenes in XRTools too. So if we look at the folder here, for instance, our staging still has scenes. So this is a good example, right? If I would just use this one directly, it would break. I need to use that staging scene in order for this to work properly. So again, sometimes I can't avoid it, but I'm trying to minimize that. Robin, thank you for watching, and I'm glad that you found it interesting. The streams are always available to rewatch later after YouTube finishes processing them. So you can always, if there's anything more that you want to know about what we're doing today, you can scrub through the video and look through. But yeah, glad that you found it interesting. Cool. All right. Yes, that's where we're going to keep it. Thanks everybody for watching, and I can't say 100% for sure that I will be streaming tomorrow, but I am going to go try and yeah, pick it up there. So thanks everybody, and see you next time.